Okay, if you don't want to be recorded, you can of course keep your well, your video should be off in the webinar mode, but you can of course change your name under participants. That also might make you look like a Zoom bomber, so maybe don't change it to something inappropriate, but please change your name if and thank you so much for being here with us. That said, if you'd like to, you can also feel free to change your name and append your institution, which is nice, especially context as you ask questions. We do have the Q&A tool available, or also feel free to use the chat, and we will naturally, as the question lends and as the speaker's willing, answer things as we go or leave things towards the end. And so we have a speaker today, and then right after, we're going to talk about an upcoming reoccurring activity that we're going to be launching from Go Fair US called Whips and Chips. With that, I'd like to turn it over to Chris Erdman.
Hi, everyone, and thanks again for attending. I wanted to thank our speaker, Dr. Anna-Lena Lamprecht. I'm excited she's here because she has one of the go-to papers that I think on software and on FAIR and software. And in addition to data, we also want to talk about software in this community, and it's great to have her talk about some of her work, including the paper, but also some of the other work that she's doing with advancing the FAIR principles per software. So I'll leave it to Anna-Lena to introduce herself. Thank you again.
Yes, thanks for the introduction, also for inviting me. It's always like a great opportunity to talk about the work we have done so far again, and also the work that we are still doing, and taking this also as a chance to involve more people in the discussion, because I mean, FAIR and research software is really an ongoing adventure. So if you're interested to join us, I will tell you at the end of this presentation how you can do that. Briefly, first to begin with some words about me, because I think very few names in the list I recognize, so I haven't met too many of you before. So I'm currently an assistant professor of software technology, so at the Department of Information and Computing Sciences in Utrecht University in the Netherlands. As we discussed briefly before, we're also in a strict lockdown at the moment and all working from home, but yeah, we're getting used to it, I guess. So my main areas of work, very broadly, I would say software engineering, recently more with a focus on research software. So research software engineering is being coined as a standalone term and own scientific discipline. And what I try in particular is to combine these with a world of, let's say, formal methods. So applying formal methods to improve the construction of research software. I think this is my broad aim in research. A bit more concretely, I would say, like, current focus of my work is on the one hand side, scientific workflows, and also how you can use formal methods to improve their construction processes, FAIR software with this work here. And because I'm also a teacher, it's a lot of like education in RSE, so research software engineering and computational science in general. That's what also keeps me busy. I'm not only active in the field of software technology, but also in application areas. Mainly at the moment, these are life sciences and geosciences, a bit of my own. So I have a bit of a mixed background, also having done a master's halfway in bioinformatics. And in my postdoc time, I had a lot of contact with the geosciences people. So this is how that grew. But today we're going to focus on the FAIR software work. And the plan for today is roughly the following. So we do a short recap of the FAIR data principles. So I assume that most of you are quite familiar with those, but I just want to make sure a bit that we are at the same page and refreshed and know what we're talking about. And then we dig in deeper a bit, what is data and software? Why do we need to talk about these things separately? I will tell you a bit about the work that we have done to kick off this discussion. So incidentally, this is also the title of the paper that Chris mentioned, so towards FAIR principles for research software. And this was really a starting point of discussion. This is still ongoing, and I will also tell you about what the outcomes so far are. So there's a few more papers, a few more things to go to, a few more things to check out. And then finally, yeah, there is a big community around this topic now, and what can you do to get involved? Because there's, of course, different ways to do that. So to recap about this fair data principles, I thought we would do that in a bit of interactive way. You might have guessed already, so you might see the mentimeter.com URL. And I'm going to use this Mentimeter thing with you throughout the presentation to interact a bit with you. The way it works, so maybe you've done it before. So what you need to do is to go to menti.com, so either on your phone or in a separate browser window, and type in that code that you see there. And then you should see that question and should be able to answer it. And the first question is just to you, are you familiar with the fair data principles? And my assumption would be here that most of you are, but I'm still interested in your self-assessment on this question. So people are finding the right location. This is good. We have one no. We'll give a very brief introduction then. Okay, while people reply, I'm just giving the short summary. So the fair data principles. So these F, A, I, and R stand for findable, accessible, interoperable, and retrievable. And the principles say that all scientific data, and this is mostly digital data that we have in this time and age, they should be these four things. Then there's a more concrete work that says what exactly that means, how you achieve that. But it basically has to do in what way you package your data, how you provide it with URLs, how you provide it with metadata that describe the data in finally then a fair way. Okay, for the person who answered no, let's see if we need to answer more questions as we go, but this is very roughly the idea of the fair data principles. So the next slides are actually kind of like quiz questions for those who answered yes, especially, but also for those who answered somewhat, to check a bit if you're really familiar with the fair data principles. And this quiz means, the Mentimeter will ask you to enter a player name if you haven't done it so. So at the end of the question, we will see a small leaderboard and see how you're doing. So let's see how that goes. First question is, and the structure of these four questions is always the same. So you see and the players are getting in. You always see a statement. Yeah, so metadata are assigned a globally unique and persistent identifier. So this comes from the description on the, for example, gofair.org website. And the question is, which of these overarching principles is that? So the unique and persistent identifier, is this for findable, accessible, interoperable, or reusable? And the question is, do you recognize for which principle this is? So this is literally copy and paste from the website. Thumbs up, let's see. Yeah, so this one probably was not too hard. So the identifier is indeed the findable principle, because that says if the findability is enabled or requires really a globally unique and persistent identifier, because it means if you have a URL, for example, that points to a resource that should be globally unique, like an address, and persistent is that it also requires this identifier to remain stable, like a DOI, for example, that does not change. You will always find the paper. Whereas normal website URLs can be quite subject to changes and would not fulfill this requirement. Okay, next question. Another one of those, so two questions. 2 or 4. So that the metadata and data meet domain relevant community standards. Which principle is that? It's a bit more difficult, I think. I hope you're not all checking the website now, and that would be cheating. Interoperable. No. That usually works, that people get it wrong here. The domain relevant community standards are in fact the reusable principle. So two people got that right. I agree that they overlap a bit and they're interleaving. So it's many of the aspects that are actually in domain relevant community standards could also be interoperability. But if in the plain list at the gofair.org website, you have this as a reusable principle. And the point here is the domain relevant and community standards, because that is what these descriptions is what it makes reusable for peers. It's not so much about the interoperability of the formats, but strictly speaking, they're of course related. Okay, third question in this collection. Is some principles. So metadata and data are retrievable by their identifier using a standardized communications protocol. So the standard, what this means in technical terms is, for example, if you have an identifier like a URI or a DOI, if you put that into a browser, the HTTPS standard communications protocol will retrieve it for you. That is what is meant by this. So most people here are for accessible, and that's correct. So the other answers given here, findable, interoperable, I would agree it also has to do with those, but in terms of the principles is accessible. Okay, final question in this small quiz is the qualified references to other metadata. And that means basically that the data sets can refer to other data sets or to other metadata sets. And how they're interlinked and qualified, I mean, it's not just a reference, but also a reference that is a clear, well-defined meaning. And it's a bit from the semantic web context. Which for principle, you have interoperable. That's also the correct one. So it's good that many of you chose that one. And this is really, so the qualified references between data and metadata is really about interlinking data sets and so making them interoperable. Okay, let's see how you did here in this quiz. I think you all have nice fancy nicknames. Yeah, so the hustler has won this small quiz. Congratulations. So this is about fair data, but I'm happy to see that it went pretty well for most of you answering this quiz. And I think we're now a bit like active again and reminded of what these principles are. I will have a bit more interaction with Menti in the following, but that will not be in the shape of a quiz, but more in terms of like free form input that we can discuss. So FAIR principles, findable, accessible, interoperable, reusable. They have been published only in 2016, so it's not so long ago. It's not like roughly 5 years. We have them under this really meanwhile famous paper, the FAIR Guiding Principles for Scientific Data Management and Stewardship. Potentially you have cited it yourself already, because I mean it has literally thousands of citations meanwhile. So it's really quickly kicked in and got a lot of attention and a lot of impact. And I don't know how the situation is in the US, but in Europe, so in the Netherlands in the first place, but also generally in Europe, also funding agencies have picked it up quite quickly. For example, here already a statement from 2018, the European Commission has already put a statement in one of their report that FAIR is important and that central to the realization of FAIR are fair digital objects, which may represent data, software, or other research resources. And what is interesting about these two statements is, the statements is that the European Commission report mentions digital objects and says this can be data, software, or other research resources, while at least the title of this original paper mentions data and data only. And maybe in retrospect, this is a bit like unlucky because it led to the FAIR principles being perceived mainly as the FAIR data principles, although they were from the beginning. So if you really look at that paper, a sentence like this is actually in there, so that the principles were always meant for all kinds of digital objects and not just data. And that comes a bit because you have this, on the one hand side, these 4 foundational principles, how we call it, so the F, A, I, and R. And on the other hand side, you have a list of these 15 guiding principles that you would also find on the GoFair website that come from this original paper that talk very much about how this really is the case for data. And so FAIR data is much more commonly known than FAIR software. And for FAIR software, we don't have this reference list of how the principles work. So that is the main guiding questions of this FAIR software work, actually. So can we apply them directly? Do we need completely different principles? Or can we maybe reuse some and have to reinvent others? So that's the starting point of the discussion. And one thing that we need to understand for that discussion is about, what is now the relationship between data and software? So is it now, can we treat it the same or can we not treat it the same for the purpose of this discussion? And as I said, so it's an ongoing discussion. The aforementioned paper is certainly kind of like a milestone that kicked the discussion off a bit and provided a few foundational thoughts about starting points for further discussion. It's interesting because it was really in the first half of last year, it was one of the most viewed articles in this data science journal, which I think really confirms that it's important discussion to have at the moment. And what I want to do now is to take you through some of the central thoughts and ideas in this paper, and we're going to do that in an interactive way again. So I do hope that you have still your Mentimeter windows open. And my first question to you is, what is data? And this is now not a quiz question, but you can freeform type in your answer. And I'm just curious to see what you will say here. I'm going to comment a bit on what people write. So it's anonymous, no one can see who you are. So dare to be brave and just type the first thing that comes to your mind. I mean, you probably work with data all the time and deal with data all the time, but if someone asks you, what is it? What would you reply? So first few answers are in. Information comes up a lot of times. So information you want to analyze for insight, quantified and searchable information, facts, metadata, more information. Input for some task. Data tables is an interesting answer as well. So tables are tables data, or are tables a representation of data or a container for data? That's an interesting one. This one is also interesting. An artifact of an event, thing, nugget of information. Well, we have information again. Information artifact from observations. Yeah, facts and observations I also see a couple of times. Compilation of data points. Qualitative or quantitative digital information. Yeah. So I'm not going to pick one of those, right? I mean, there's many definitions to how people would define data, but I don't think anything here that is obviously wrong because it very much depends, of course, on your perspective. how you look at your data. And there's more technical ways to look at data, and there's more, let's say, application-oriented ways to look at data. No, but we have a lot of facts, information, data points, knowledge, all these kinds of data. Okay, let's maybe continue to the next question, which is, what is software then? I also suppose you're using software on a daily basis. So what is that? How would you define it? Program run by a computer. That's the first answer. Nothing wrong about that one. Second is a system designed for a specific task, and a bit of a high level definition, yeah. So it is instructions for computers to perform the specific task. Come back here again, indeed. And interesting here, it mentions also including interactions with human data and other computers, yes. Software mechanisms for manipulating or visualizing data. I think second and fourth answer both kind of assume that it's carried out by a computer, although they don't say so. Computer collect information, perform specific task. Yeah. Something that tells a computer what to do. It's a very basic and technical, but certainly also correct definition. Digital instructions for machines, yes. Okay, so I do think, I mean, everyone has an idea about software, but and data, but it's still good to try to define it a bit. We have done that. Okay, now it's getting a bit more interesting to relate those two. And the first question this year is, if you think about data and software again, what do they have in common? If anything. What would you say? Are they completely the same? Machine readability is a commonality, yes. It also means that often, at least like they're usually in digital form, so and processed by computers. Software is an artifact of data and code and can generate the data. Yeah, that's an interesting one. I'm going to comment on that on a bit later again. Because yeah, sometimes people say the software is a is also data. I'm going to comment on that a bit later again. Hopefully, machine actionability. Yeah. I mean, for software, that is often more easy to see than for data. I mean, software is executable, but yeah, how well a machine can deal with data depends very much on how the data is provided. Software can be used to analyze data and create data. That's maybe more different than a commonality, but that's okay. Data is organized in information. And for a software system, software can be broken into data points. Yeah. Versioning is also something that I have in common. That's a good point as well. Although I would argue that usually versioning plays a bigger role for software because there are more frequent versions, but there are special data sets where versioning also plays a big role. But then depending on the field you look at, sometimes you also have data sets that don't do versioning a lot. Okay, so some of you already went into the direction of the next question, which is actually about the differences between data and software. So if you really would need to distinguish them, that the one has and the other doesn't, what would that be? And is it significant? Or when you say that there's actually not really a difference? First answer in is that software can modify other things, whereas data on its own does not. Yeah, I like that one, and that's an important distinction. Yeah, the next one that comes in is also performing the action, and the other is acted upon. Yeah, software is using data to perform some task. Data is interpreted by software, and many answers in the same direction. And I also like this one. I think of software more like a verb. It is for doing something, and data is more like a noun, what it's done to. I like really that analogy and distinction. And the good contributions over time. Data may be finite. Software may develop over time. Yeah, I think for both, contributions over time are possible, but you see the development much more for software in general. Yeah, but it's really good to see that the central difference really, like software is executable, it does something to data, where data, as the one data set as such, is, yeah, in a sense, static and more the input to something like software, or the input for analysis and the input for some actions. And that's an important difference. Okay, thanks for your answer so far. I'm taking over for a couple of slides. So this discussion, whether between software and data, was really an important one in the beginning, just to structure the thinking and to understand whether we actually need separate FAIR principles for research software, whether we need this discussion or not. And so this is like a separate section in the set paper. And starting point of this was actually a statement that you very often hear from people. They say, software is just a special kind of data. I mean, no one put it really here literally in those terms, but I think in the first, or in some of the answers to the questions, we saw something like that. And well, that's not wrong, but it's true when you take a quite technical perspective on software and data, or on computing in general, because then you would say in a computer system, at the end of the day, everything is data in the sense of being a sequence of ones and zeros in memory. And in that sense, information stored in the computer, as well as instructions or software stored in the computer, are data, and both are just a special kind of data. And so in that sense, software would just be a special kind of data. But if you look at the FAIR discussions, then we take a slightly different perspective, because FAIR, for example, they talk about the digital object. And in that perspective, data is a digital object, and software is another digital object, but next to data, not as a special case of data. And this is a much higher level perspective to look at the things, but we found this take on it to be much more useful for the discussion of FAIR, which happens on a really more domain level and not so much on a computer technical level. Yeah, so this is what the lower perspective is what we would apply in the following. And that also means that data and software, they share properties of digital objects. For example, like the possibility of having a DOI, so digital object identifier, assigned. This is something they both can do. So there's a common property, and there's a FAIR principle about the unique and persistence identifiers. DOIs are one, so that principle would apply to both, because they both can have this digital object identifier assigned. So there, the FAIR principles for data and software would not need to differ. But what about these differences that you highlighted, for example, software being executable? Does that change anything? Software having more dependencies, does that change anything? Does it require separate principles? Things like that. So therefore, it's important to understand whether we treat software as data, or if we say software is something different. And for the sake of this discussion, we found it much more useful to say it's something different, but they are both digital objects. Okay, another point in this discussion. So I talked about research software before, but I did not really define what we mean by that term. So for the paper, we went the pragmatic way and applied one of the existing definitions at that time. So by Simon Hattrick and colleagues who said that research software is software that is used to generate, process, or analyze results that you intend to appear in a publication. I'm going to say a bit later on the ongoing discussions about this definition, because this is also work in the FAIR for research software community. But for the moment, let's just say, okay, research software can obviously come in many forms for many purposes, many distribution channels. And what you traditionally see that in many of these research software projects use open source licenses, or free and open source. The acronym is FOSS here. And the interesting thing is, if you look at what they want to achieve, there's a clear overlap of objectives, but yeah, when you take a closer look, you can see it's not the same how they do that and how they want to achieve those aims. So FOSS is very much about open source code, open licensing, whereas in FAIR, open data is not a requirement. This is one of the misconceptions about accessibility. Often in FAIR, you see FAIR only mandates that you clearly state how data can be accessed, but it's not required that they are open per default. And there are good reasons for that. For example, I mean, privacy, sensitivity concerns in healthcare studies, for example, you cannot just release the patient's data to the open without their consent, right? So, it's very reasonable that's in there, but these things are not in the same way valid for software. You could even make a stronger case that you could say, okay, software as a method, there's even a demand to make it available. So it should be open because it's the method. So we don't have a conclusion on this yet. And this, should FAIR software require FOSS is still an ongoing discussion. I would briefly be interested in your spontaneous opinion about that. So what do you think? So should FAIR require software to have an open license? And why or why not, what would you say? First answer in says, no, it's just not always possible. So it would be unrealistic to enforce it. Second answer goes in the same direction. Yeah, it should be an ideal, but not required, also because it's not always possible. Also, no, there are legitimate reasons for closed licenses. Yeah, could be a best practice versus a requirement. It's interesting. You're very much agree on the no, it should not be forced. Now we see other answers coming in. They say yes, it allows others to make improvements. Yes, whenever possible. Ideally, I think it should require this. Yeah, so you're very diplomatic in that. I've seen sometimes discussion that people are very much on the yes side and say, of course, all research software needs to be open. Otherwise, it's not good research. It's not open science. But people with a bit more experience sometimes say, no, it's just not always possible. We need to accommodate also special cases. Okay, I leave it at that because it's really an open, we won't solve it today. And it's one of the interesting dilemmas to discuss further. Another thing that I briefly want to mention is the relationship of FAIR and software quality. So as soon as you start talking to research software engineers or RSE about software, quality comes up as a concern, right? So if the software is not good, then also the results it produces will not be good, and then research results will not be good. And there was a very much discussion very quickly whether FAIR can meet the expectations that the research software engineers or the programmers would have for making software fair and software good. And the answer was, well, it's not so easy to answer, but what helps is to distinguish between two things, namely what we call the form and the function of software. What we mean by that is the form is very much like the how a piece of software is provided, like the file that you download, the code that you check out, how that looks, how the code is written, how documentation is there, if there's documentation, how well it is done, if the code is structured in a way that is maintainable. But really, like you could look at the code and judge that. So that is a bit meant by the form of software. And on the other hand side, we have kind of the functionality of software that you only see when you really try to execute it and observe what happens there. And these are aspects of, for example, like whether the algorithm implemented is correct, if it does what it's supposed to do. It's about maybe software security issues, computational efficiency. These are all things that really matter, but we found those not really to be in the scope of what FAIR does. So FAIR is very much about how the thing that you can download and get somewhere, in what shape that is, and in what shape its metadata is that describe it. And if you think of it, that's actually also true for data. Yeah? So FAIR does not talk about the quality of the content of the data. You could have really rubbish data and have it completely fair. And that brings to another question. So this is a question not only on software actually, but also on data. So should FAIR, and it does not at the moment, should it also actually take content quality into account or not? I'm again interested to hear a few of your opinions on this. So should we have a FAIR principle that also says, I don't know, there's a quality value or some quality score that should be higher? So first answers here say no, in principle. Yeah, so both these answers actually say, so this is like quality and FAIR is something different and they should not be considered together. Third answer says yes, it should be. If data is not of quality, then results produced from such data are also questionable. Yeah, that's the dilemma of there. Not exactly. Yeah, I know. Possibly connected with other FAIR letters. Yeah. Yeah, but what your answers also highlight a bit that quality is important, so we should somehow pay attention to that. But yeah, it's questionable whether FAIR is the thing then to achieve that. Well, also, quality will be determined by the publications is another answer here. Yeah, we hope to rely on the peer review to determine if the content is also what that is. And FAIR is much more like a technical means to make things possible and to make the process good. But in itself, it does maybe not ensure the quality of the research. Yeah, and an interesting comment here is also that I wonder how to make all the criteria for different disciplines or data types. That's indeed an interesting one, because already in the application of the FAIR principles like we have now, community or domain specificity is a major concern. So usually you really need to adapt all these to your communities to really work well. Okay, but as I said, so that's a bit of an other meta and ongoing discussion. So we'll leave it at that. I will share the answers, by the way, with you afterwards, as Chris said. Very briefly, so I won't go through these tables here, because this is stuff you can read up in the paper if you're interested. So what we did as an exercise for this FAIR paper was actually try to map all these 15 FAIR guiding principles for data and see how they could be translated to software. And for many, as you see here, for example, the F principle, the findability principles, it's often just a question of rephrasing them slightly. Mostly that means replacing metadata by software and its metadata. Very similar for accessibility. They were slightly rephrased or even remained completely the same. So there was not a lot to change there. The most interesting sets of principles were then more for interoperability, where interoperability in itself was not very well defined. And then so how do you translate these principles? And this is also, I would say, maybe the most preliminary of these translations and new FAIR principles. And this is really something that needs a lot of further discussion. So I will leave it at that for the moment here. Just note that for the reusability, then the it was again more a matter of rephrasing, and just noting that again, like the community input here for making good metadata standards is important. So I promised like a short summary of reading lists, and you can take that later from the slide. So it contains, on the one hand, this the paper that I talked about already. There's a report available on Zenodo that has a bit more practical take on things. So there was a global sprint in late 2018, I think, where we discussed about what are top 10 things to make things fairer. And we also discussed a few things about software that fed into that paper actually. There's another interesting paper, Fair Computational Workflows by Carol Goebel and a group of other people that looks into FAIR, specifically on workflows, but workflows are then again a specific kind of research software. So there are some overlaps between these thoughts. A third paper in this collection, with this or fourth in this list, is by Willy Hasselbrink, and Simon Hedrick is in there, and a few other people who looked into FAIR more from an angle of open research software and open source software. It's also an interesting read. It really takes different perspectives, but comes to similar conclusions. And the latest edition here is a report from the FAIR is Fair project that does an assessment report on fairness of software that also builds up upon the previous initiatives. So this is, if you're interested, that might be a bit of a homework for you to read upon. What question people often ask though is then, okay, what can we do practically? So I don't want to read all those papers and be engaged in the theoretical discussion. So what can I just do? And there, I think a good reference at the moment is the website 5 Recommendations for Fair Software that is hosted at the Netherlands eScience Center. It's available at fairsoftware.eu. That just says, okay, we have 5 basic recommendations that you can do to make your software fairer. It might maybe not in the theoretical academic sense fulfill all the FAIR principles completely, but if you do this, you will have gone a long way towards making your software fair. And these 5 principles are just, use a publicly accessible repository with version control. So if you put your code on GitHub and it's publicly accessible, that would be done. So GitHub is, I think there are other repositories, but GitHub is really the de facto standards, I think, in the scientific world. Second recommendation is there, add a license. And in these recommendations here, it does not say that it needs to be an open source license, but add a license so that people know how they can use their software under which requirements. A third recommendation is register your code in the community registry. And there it really differs between communities if these registries are actually in place. So I have no idea where most people here come from, but for example, in bioinformatics, there is the bio.tools, is a large community registry, I think with 18,000 tools meanwhile. And it just means that if you register your code or your software in that registry, people from your community can just much easier find it. Once it's because it's in a place where people look, but also because this registries help you to fill in good metadata for your software. They have predefined schemas, they will guide you through the process so that you don't have to come up with that yourself. And they're also usually optimized for search engines so that people look for specific functionality. They're more likely to find it in there than on plain GitHub, for example, or on your own website. Fourth is also enable citation of the software. So software is also a major product of scientific work. So give credit to the creators of the software. Do that. There's ways to cite software, whether it's a software paper or the software citation file directly. So there's different possibilities. And the fifth, it's a bit use a software quality checklist that will take you through the steps of ensuring that the basic quality aspects are already taken care of. And these are also often very community specific. So for example, there's a quality checklist for R packages that you can find on the web and so on and so forth, depending on what your platform is. And if you like this principle as an organization, it's also nice where you can go there and endorse this. So the website will show that that your institution or organization endorses the fair software recommendations. If you like to do that, East Science Center will be happy to accommodate that. Okay, very last question. So this is the final Mentimeter questions to you. If you think about these 5 recommendations, I would be interested to hear if you do that already or not, and to what extent. So the scales here are from never to always. And if you could just briefly indicate where you are on those scales, it would be interesting. So for one, okay, in the registry, no, but in the repository, and it has a license, and the others are not so exposed. The quality checklist, we have 1 yes, 1 no. Let's see if we get a few more. Yeah, let's see if we get more answers, but this is a bit the rough picture that we often see. So very many people already do the first 2 things. So people have their code on GitHub and people give it a license, but the other ones are not so widespread yet for various reasons. But I think this is also something to work towards as a community, that gets more toward the side of always in the future. Thanks for that. So that was the final Mentimeter questions. Now a few final remarks on what can you do to get involved. So I think the main starting point to remember is this RDA Fair for Research Software Working Group. You find on this link there. So this is like a joint venture of being an RDA working group. That is where the websites are, but also Force 11 and the Research Software Alliance are involved there. And in this initiative, basically, there's 4 subgroups working on different things. So it's about looking at Fair for Research software again to see if you would come up with other ideas to approach that, looking at fair work in other contexts. Here also what I mentioned before, a clear definition of what actually research software is also one of the projects, and also continuous review of new research related to software. So all these 4 subgroups started work in summer and have some intermediate results, but they will be open for further consultation yet and are not yet finished. So you can still go in and join there if you're interested. A bit of maybe lesser commitment would just be to join one of the next events. So early February, there's a town hall meeting on the RDA working group progresses that you can join. There is a new webinar series and hackathon starting in also end of January that will on how fair are you, that involves fair software. And the SSI collaborations workshop also has fair research software as one of its 3 themes this year. So that will be something to check out as well if you're interested in that. And finally, just acknowledgements. I don't dare to put concrete people here because I would forget too many. So I would just like to thank all the numerous people who contributed to the discussions and keep the work going. And that also includes actually your own answers to the Mentimeter here today. So thanks again for that, for coming, for listening, for your input. And last note here, this is what happens when you use PowerPoint online for making your slides. The designer wants to be clever and suggests pictures, and if you type fair a lot of times on your slides, then this is the picture it comes up with. And I wanted to use it at least once.
At least there aren't clowns.
We gotta find those.
Thank you, Anna-Lena. There's one question, actually. I don't know if we have
Right.
enough time, because we wanted to branch into our other conversation. So I don't know if you want to answer the question in
I can go
chat.
quickly. I see it. It's there.
It's in chat,
The Q&A.
yeah.
Oh,
And
chat. I see
Q&A
another
too.
one in Q&A. Yeah.
It's the same one, yeah.
Yeah, the software citation contributes to FAIR. Now this is about, I mean, if you think about FAIR reuse and also the quality reference of metadata, this is what the citation enables. And it's something that is not so obvious from the main principles, but citation information is something that should be in the metadata of the thing. That is the basic idea of that one.
Yeah, thanks. If you have anything else to add in the chat, that would be great. I know if it helps, but thank you again. And we'll, if there are additional questions, please use the chat. But we also wanted to introduce our upcoming session, and I want to hand it over to Christine.
Thanks so much, Chris, and thank you, Anna-Lena, for a really engaging session. And yes, I think we all really enjoyed testing our knowledge and also exploring some of those ideas. So I'm going to share the screen in a moment, and I'll paste the link in the chat. But we realized we've only done a few webinars as GoFair US, and we realized quickly that the people who attend the call are a set of experts as well. And so we would like to make this interactive the way Anna-Lena showed us it can be, but also give others a chance to share their work in progress and point out areas where we could be working together to really look at what are the specific challenges that we are facing around FAIR implementation, especially here in the US, although anyone is able to join this. If they are happy to join in the evenings in Europe or at an odd time anywhere else in the world, that is fine too. But I think the US flavor includes some knowledge of lower amounts of funding and a lot more, blazing a trail. So with that thought, we are going to try this out and we'll iterate on it as needed. Let me just paste this link in the chat for those of you who want to look at this later. I did not name this tool. It has the worst name ever, but it is actually, I found it in other interactive things I've done online, fairly intuitive and easy to use. So we will forgive it for being called Jamboard. But basically, it's the equivalent of being in a room together and using stickies. And so the idea here is that for our next session, we would like to give people a chance to talk about things that they're working on. It doesn't have to be completely finished. In fact, it's often more interesting to hear about what someone has in the pipeline and where they are with it and where they think it's going. And then I think the natural thing that it will bring up is also the gaps. And so those are the chips. And we recognize this might not be the best name ever, but it is very sticky and it was easy for us to remember. And someday in person, we will have a lot of chips together. So if you have something that you're working on in progress and you'd like to speak about it for 3 to 5 minutes, maybe no slides even, all you do is you add a sticky. Let's see if I can remember how to do this, right? So you're going to add a sticky note. We're using blue for the works in progress. And then you just put it in here. It'd be great if you'd also put your last name, unless you have a really recognizable first name. I don't want to count out Cher or somebody like that who might be following what GoFair US is doing. And then just throw it under here. Our GoFair US coordinator, Alex, she'll also be monitoring this and making things look neat. So don't stress about that too much.
Christine,
oh, sure.
we're getting messages about access. Like people needing access. Yeah.
Okay. Oh, okay. Okay, now we have found the problem with Jamboard. Because it's a Google thing, it's connected to our institutional account. So after this, or actually I might stop talking for a minute, and if Chris would take over talking, then I can fix it, because it's hard to do two things at once, I found. But one last thought, if you do end up adding a chip, so let's say instead we're going to make this a chip, right? And it's over here. Take a read of the others before you add one, and you might find one that you also think is important, and just add your name to it. You won't necessarily be asked to speak about it, on your own, but this will give us an idea of things that we could work on together, or things to watch out for as we try and bring in all of the other activities going on, across the globe, and bring the best back to you. So let me fix the access. Is there anything anyone else from the office would like to add about how we're hoping to have this work? And let me fix the access while we're doing that.
Yeah, I think this was an inspiration from our last meeting. I think the last session, we had a lot of people talking about how they were trying to implement FAIR. And so we thought this was a great mechanism. And Christine came up with this idea of what they use at San Diego Supercomputing Center, of where they present on their whips and chips. And I don't know if Christine, you mentioned it, but we are expecting these to be fairly short, because we're trying to cover, as much as we can. So I don't think we've come across a exact time, but I think use maybe 5 minutes as a placeholder to present, and potentially 5 to 7 minutes to discuss, as far as getting feedback from everyone. I'm not sure we'll have enough time to cover all of them, but I think the plan is to try and cover some of the whips and chips from the community, and really I guess leverage Go Fair US to help with your projects, the community as well. So
Yeah, just to say a bit more about that. So this idea comes from a conference I've attended, and I think it's similar to the idea of a BOF, in that it's no one community owns the idea, and it's just a model used when people get together. But the whips in particular, the model is you're in a room together, and people raise their hand and then come to the front of the room and just speak extemporaneously for a couple minutes, answer a few questions, and you go on to the next one. So it's lightning talks have been a bit perverted, I think, in the age of Zoom, in that people still sometimes come with a large slide deck, and it's 15 minutes is not lightning speed. So it's maybe what people intended with lightning talks, but the other idea is doesn't have to be fully formed. You don't have to have all the answers. It's a time for people to know who to talk to if they're embarking on a similar journey, so that maybe you can work together, or at least stand on the shoulders of one another. Maybe not the best metaphor, because that who's on the bottom. Anyway, so any other questions about that? Hopefully people have been able to get in. Okay. Now it looks like another question has come in for Anna-Lena, if she's available for a last question.
Yes, sure.
Okay, it's from Kate Bertigan. She says, the links to the publications on FAIR for software were helpful. Are there links to sample SOPs that operationalizes the FAIR principles for databases and associated software for an organization that wants to better evaluate current projects on compliance? And then as a follow-up, as well as develop best practices, SOPs for future projects.
Right. So is it specifically on databases with software, right? So I don't have anything on the top of my head, but I would, chasing down the link collections that we have in the working group, that might be a good reference point to find something. That's a bit more specific use case. I mean, the eScience Center pages is very software in general, but there might be pointers on that website to more specific initiatives. I mean, there's so much going on at the moment. I don't have everything in my head, but I think in the RDA working group page might have some references on there.
Great ideas. Well, and I think what you brought up to me is that there probably are plenty of gaps in the area of care software, because we're really at the beginning of trying to figure it out.
Yes, yeah.
Right, and the scholarship is very recent, and so this could be a place that needs developing.
Yeah, and we really see that many of the concrete solutions really need to be domain specific, and communities really need to contribute in tailoring towards their needs. Because alone, like a software quality checklist for R and Python, for example, would be completely different. And also the cultures in the communities that use these technologies are quite different. And so they only apply to all on a very high level. And if it gets operational, it needs to be tailored to really to the needs. So there's a lot of work for everybody.
Well, thank you so much. I see that we're a minute past, and I know many people have something else that they have to be at. And Anna-Lena, you've got dinner, hopefully, coming soon for you. I know it's almost 7 p.m. or should I say 1900 where you are. Please join us. Our next session will be the 18th, which is at noon. It's a bit later. Apologies to our European counterparts. It's at noon Pacific on February 18th, which is a Thursday. And you can also find that on our website, which is gofair.us. Thanks everyone for joining, and we'll see you in February.